Login accepted.
Say the car insurance company wants to come and yell at me for some reason. Then they don't want my mail being mixed up with the bank. So therefore, they're going to go ahead and they're going to put it in a different box. Just like that, different services, different connections can come in. They can connect to these different ports, and this way, computers can easily differentiate between services and the packets that come between them. So SSH operates primarily on port 22. Of course, you can change this in the settings, but by default, it's going to be 22. The most commonly used implementation of SSH is known as OpenSSH. And I'll show you guys how to install this in a bit. But another implementation you might want to watch out for in the future is something called Dropbear. I don't personally know too much about Dropbear, but there are some problems with Dropbear compared to OpenSSH. And I forgot that Bill clicked off, so I can't. OK. Managing SSH. So let's go ahead and install SSH. Now, by default, most Linux distros will come with something called OpenSSH client. This is a client that you can use to connect to any SSH-based computer. However, if you want to host SSH, what you need to do is you need to do apt install OpenSSH server. And just to keep in mind, I've done all of these commands with Ubuntu in mind. However, if you are interested in using a Red Hat-based distribution like Fedora or Red Hat or CentOS, then you would just have to change the apt to something like yum or DNF. Then we're going to go into systemctl, enable, disable, start, stop, restart SSH. Now, I will go into systemctl a little bit later, so I'm not going to stay on that. But just know that's very important for just kind of starting and stopping SSH. And you have two primary locations that you really want to watch out for. The first one is etc SSH SSHD config. The SSHD config is the primary config file for the SSH service. The second one is the etc SSH folder, which is where you're going to go ahead and store a lot of other things, including all of the public keys and private keys for the SSH server, which is important just in case somebody decides to swap out your keys for something else. Using SSH. Using SSH is extremely simple. All you have to do is you need to type SSH, the user, at the host. So in the example that I have on the screen, you can see that I'm SSHing into a computer with the username entangled and the address of localhost. Localhost is a loopback. It refers to yourself. Basically, I'm connecting to myself here. I already pre-installed OpenSSH server on this VM, so that's why I'm able to connect to myself. You guys can see that it asks me for my password. After I've entered my password in, it gives me a huge banner, and then boom. It may look the exact same as the top because I am logged into myself on my own computer. But if you hit exit, it's not going to leave the terminal. It's going to exit the session. A couple of important flags to note. -I is if you want to specify a key file, and I will cover what a key file is in just a second. And -P is to specify a port, just in case that you decide not to use 22 for whatever reason. It is important to note that if you guys do decide to open up SSH servers with your own home devices, exposing port 22 on the internet might not be a great idea because everybody is looking for port 22, and they might just do gigantic port scans. And if they see you have an open 22, then they might just decide to see how secure you actually made it. Now we're going to talk about authentication methods for SSH. As you can see, there are a lot, but don't worry, they're not that hard. The first one is host-based. It's pretty simple. Basically just says, I recognize your computer, and therefore you're allowed in. Now, can anybody tell me what might potentially be bad about this? What's so bad about recognizing your IP address or your MAC address? VPNs exist, so you can spoof. Okay, credit to him. And so basically, it's pretty easy to fake your address. So with this, basically anybody could get in anytime they wanted. The second one is called keyboard interactive or challenge response. I'm not going to really go into it because nobody really uses it these days. The third one is Kerberos. Kerberos is a special ticket-based authentication, and it is commonly used by Active Directory. So if you want to go ahead and join your computers to an Active Directory domain, it's going to go ahead and use Kerberos for the authentication between your joined computers and the domain controller. GSS API is also another thing that's used for authentication with Active Directory. Public key encryption. Now, can anybody explain what public key encryption is? Yes.
Specifically encrypted file that the server itself or the host recognizes when it's authenticated.
Yeah, that's pretty close. Yeah, we can say that public key authentication is a very special method of authentication where you have two files. You have a public key and you have a private key. The public key you give out to everybody, and everybody has this public key. The private key you keep to yourself because it's private. And what you do is you can encrypt something with a public key. And if you send that encrypted file to the person with the private key, they can then decrypt that file. And these things are built such that it is incredibly difficult, if not impossible, to crack a public key encrypted file without the private key. Of course, these are algorithms. You can break algorithms. You can brute force algorithms over time. But generally speaking, unless you have something like a NASA supercomputer, you're probably not breaking into anything soon. Public key is one of the most prolific forms of SSH authentication and is one of the most recommended in terms of access for individual computers. You do have to be careful, though, because anybody with your private key can get in. So, for example, if I gave my private key to Dylan, Dylan can just enter any of my machines anytime he wanted to. And unless I change that, he can still get in. And finally, the last method is password-based authentication. You can just enter your password and you should be able to get in. Now, I want everybody to notice that I said plain text password. Plain text means that it is an unencrypted password. That means that when you enter your password, that is sent in plain text over the internet. Now, can anybody tell me why it's a bad idea to send plain text passwords over the internet? Either of you. Yeah, basically anybody can intercept. Anybody can grab your password and they can say, I'll just use that password a little bit later. You probably want to disable password-based authentication unless that's your only method of getting in and you're too lazy to set up a public key, but set up a public key. All right, speaking of keys, here's a couple of key things that you guys want to watch out for in an open SSH server installation. I am not going to go specifically into configuration options. However, these are certain things in the config file that you guys would want to look out for and change if you can. The first one is remote management. As I've said, SSH is primarily used for remote management of machines. However, as you can imagine, that does present security concerns because it means anybody who can gain remote root access can remotely screw up your machines or install whatever they want. One option that SSH usually has is to allow the root user ID 0, to directly log in. Now, can anybody explain why this is a bad idea?
If someone breaks into your computer and they have root login permissions, they can do whatever they want with that. You don't want them to do that.
Exactly. It is generally recommended to use a permission manager like sudo to manage whether users can execute commands or not. The second thing that you guys want to watch out for is tunneling internet traffic. This is actually a slightly more niche use of SSH that most people don't use these days because alternatives like VPNs or proxies are way faster and way better. But you can technically send your internet connection over an SSH connection, which is pretty wild. But you guys can imagine that's probably not the best idea at times. So you guys will probably want to disable that. Timeout settings. What happens if a user just stays connected forever? Did you? No. Anybody? What happens if somebody stays logged in forever? Exactly. You can just get in if you just leave and take a coffee break or something. So you need to make sure that any inactive connections are closed properly. And SSH gives you like 10 different configuration options for that. So yeah. User environment variables. This is pretty important too. What can happen is there are environment variables that exist within the user environment. And these can be set over SSH if you don't disable it, which means that you could potentially force the computer to do certain things or store certain values. You obviously don't want to do that, so probably try to disable that if possible. And versioning. There are 2 versions of the SSH protocol. Version 1 is old, it's outdated, it was replaced very quickly with version 2. If you ever see somebody using version 1, tell them not to, because it's not a good idea. Does anybody have any quick questions about SSH before we move on? No? All right. Second, we're going to go ahead and talk about FTP, which is the file transfer protocol. As the name suggests, FTP is used to transfer files between different computers on a network. Just like before, FTP does have a most commonly used port, and that is port 21. Technically speaking, port 20 is also used, but since port 21 is used for the control and port 20 is only used for the data, port 21 is the one that we're going to most deal with. The most commonly used implementation of FTP on Linux is going to be VS-FTPD. But other implementations that exist are pure FTP and OpenSSH's own bundled SFTP. Actually, fun fact, if you install OpenSSH server, you're going to get a FTP server just kind of bundled with that unless you specifically disable that. Hello, Jason. Just a quick side note here. This is SFTP is a modification of FTP. As you might imagine, S stands for secure. Secure file transfer protocol. It basically slightly encrypts the FTP connection. Of course, this is contingent on everything else being secure, but it's slightly better than just transferring your files over the internet with zero protection. And you typically secure this with SSH or SSL. Managing FTP, just like before, it's pretty simple to install or manage it. You do apt install VS-FTPD, or if you're on a Red Hat-based distribution, yum or DNF install. Then it's the same systemctl stuff, except at the end you replace SSH with VS-FTPD. The only real configuration option that you have here is etc vsftpd.conf, which is the main configuration file for VS-FTPD. Just like SSH, FTP is a pretty simple program to use. So I realized that I forgot to cut out the CD, so ignore the CD part. But I type in FTP. It opens a connection, and it opens the FTP software. I say open localhost. Open is the keyword that you use to connect to an FTP server. Localhost again refers to my own computer. So I connect it to myself. And it asks for my username. So I put in my username entangled. It asks me for my password. I put in my password, and it says that I have logged in successfully. If I wanted to exit the connection, I just hit exit. Now, for those of you guys who know anything about Linux or have attended last week's workshop on intro stuff, what does CD stand for? Change directory. So just like in regular Linux, CD here also changes your directory. You can technically do something like ls in an FTP client. However, it's a bit clunky. You kind of have to escape the shell. You have to execute shell commands. It's clunky. So the best way to do that is lcd, which is list current directory. Then you have put and mput and get and mget. Now, put and get basically are the same thing as put in a file to the computer or get a file from the computer, upload or download something. But does anybody want to hazard a guess to what mput and mget stand for? Yes, sir. Not quite. The M actually stands for multiple. So what you can do with mput and mget is if you don't want to just download one file, you can download multiple files at the same time. It makes it so that you don't have to type in a bajillion put commands every single time. Yes, sir. Yes. Exactly. Yes, it's a copy. There are ways to remotely delete files, but we're not going to like concern ourselves with that at the moment. If you do want to look it up, you can just look up like FTP tutorial and it'll show you how to do that. And honestly, most of the time you have something like FileZilla, which is a client for FTP, and you can just kind of, like in Windows, you just drag and drop your files and it works. So, all right, just like with SSH, we have a couple of key configuration options that we might want to change. Anonymous access. As implied, anonymous access means that anybody without any user, without any authentication can connect to your server and they can take a look at what's inside. I don't think I need to tell you guys why this is probably a bad idea, especially if you keep all of your passwords in an Excel spreadsheet like my mom does. So sometimes you might want to disable anonymous. Local user access. Let's say that I have 50 local user accounts on my server. If I enable local user access, then anybody who has an account on my computer can access all the files remotely. Sometimes you might want to disable this because sometimes you've joined the computer to a domain and you don't want to have any local user access. So you might want to disable that, but it's usually safe. Write access. In computer language, write basically means make a change, make a modification. So if you want to allow or disallow users from writing files, that means like uploading, modifying, or even deleting, then you can disable that. So if you have something that's read-only access, you only want people to, for example, take a look at the files or download them to your computer. You don't want them to upload. You don't want them to modify. You don't want them to delete. You can go ahead and disable write access. chroot. Now, chroot is going to be the user's own home directory. And what the chroot option does is it forces a user to stay only within the files and folders that they personally have on the computer. This is useful if this file share is individual per user. And if you don't want your users to be able to suddenly go into Etsy and modify all of the login options in PAM, then this might be a good idea. User list is if you don't necessarily want to just have anybody who is a local user access it, you can enable a user list, a whitelist, to allow people or a blacklist to deny people. And then finally, you also have the option to turn VSFTPD, which is by default an unencrypted FTP server, to an SFTP server just by adding an SSL cert. Now, for anybody who has installed an SSL cert on computers, this can be a little bit annoying sometimes, but it is definitely worth it for the little bit of extra security that it does provide. Does anybody have any questions on FTP before we continue? No? All right. Then we will go ahead and move on to web servers. Yes, these are pretty colorful icons. You guys can see that we are going to be covering Nginx, Apache, MySQL, and MariaDB. Now, when you hear Apache, you might think of an Apache helicopter, but that's not what we're talking about here. So please get the military out of your minds for the moment. What is a web server? A web server allows the hosting of multiple files. While technically speaking, most people will just use it to host a web page, you can technically host other files, and that thus a web server does host files. The most common web languages are HTML and CSS together, PHP, which is a little bit older, JavaScript, Python, and regular Java, but only use it if you're a boomer. If anybody calls HTML a programming language, please take the time to explain to them that it is a markup language, not a programming language. It doesn't program anything. It only gives you styles styling guides for how to style the content. A LAMP and a LAMP stack. This is one of the core fundamental concepts in terms of web servers. A LAMP stack stands for Linux, Apache, MySQL or MariaDB, and then finally PHP, Python, or Perl. These days, the P will tend to stand for PHP or Python, but in the earlier days of the internet, you would use Perl. LAMP stacks are the exact same concept, except you replace Apache with Nginx. But the most common configurations you're going to find are MySQL servers and PHP. Let's talk a little bit about the differences between Apache 2 and Nginx. Both of these are full-fledged web servers that can host any kind of content that you really want. Apache 2 is the slightly older of these two projects. It is a venerable, it is a strong, it is a very good option if you want to host a web server. It is extensible. You can add different functionality to Apache just by installing different modules. And it generally can do a lot. The only unfortunate thing about Apache really is that it is incredibly resource intensive compared to other web servers, and it also does things synchronously. What that means is that it executes tasks in order. For example, you have task 1. For example, you want to serve a connection over here. Then you serve that connection. But if you have 30,000 connections coming in at the exact same time, you're serving it 1, 2, 3, 4, and so on and so forth. So connection number 30,000 is going to be waiting a while until their content is delivered. Nginx, by contrast, is a much more modern and efficient web server. Nginx is also configurable, and it's also quite strong. So don't think that don't think that Apache 2 is the only stable option here. Nginx is also quite stable, and it's become one of the backbones of the internet these days. But Nginx is not that great with dynamic content that does change a lot. And it does come kind of bare bones. If you want to add some content and functionality, you do need to add third-party modules. But because Nginx is asynchronous, which means that it can execute tasks, multiple tasks at the same time, it can do tasks out of order. You can do a lot of extra things, such as load balancing. Load balancing is when you have multiple servers that all handle the exact same web page, so that the 30,000 connections are not put on one server, but you can put them on 10,000 different servers, for example. Caching means that you save content so you don't have to keep fetching it from the disk every single time. WebSockets is a really useful way for you to have dynamically refreshed content. URL rewriting is similar to proxying. You basically just take one URL and you transfer it to another. WebRTC is also used for dynamic content such as voice and video. And reverse proxies, I'm not going to lie, I forgot it off the top of my head. My head got a blank. If I remember, I'll explain later. A couple of web server facts. Port 80 is for HTTP, which is Hypertext Transfer Protocol, unsecured. And HTTPS uses port 443. And when I said a couple of facts, I meant one. So we're going to go ahead and move on. Web content over time. It is important to note that web servers are programmable. They're modifiable. The content that you can add is virtually limitless. If you want to have a web server, you can basically put anything you want on there legally. The first thing that we started out with was HTML, hypertext markup language. And it was great. It basically gave us structure to any content put on the internet. But if anybody here has ever seen a pure HTML website, you'll know that it looks a little bit empty. It has zero styling, and it looks like it was made in the 80s. So then we came up with something called CSS. CSS stands for Cascading Style Sheets, and it basically allows you to add colors, fonts, different images and stuff directly integrated with HTML. And CSS is great. It added so much color, and it added so much functionality to these new websites. But if you guys have seen pure HTML CSS websites, or if you have created those from scratch before, you'll know that they still look like they're from the 80s. So then people came up with something called Java applets, which are tiny little applications written in Java that do run in your browser. And it's really cool because it added a lot of cool content, but it was really slow because you're running a full Java implementation directly in the browser, which is not great. So then Adobe came up with something called Flash. Now, who here has played a Flash game? Yeah. So therefore, you know what Flash is. Flash was a really cool way of adding content. Games were written in it, and it was great. But for those of us who've also played older Flash games, we also know that Flash was unfortunately deprecated a couple of years back because basically it was so old and so clunky that it was just insecure and had so many problems. So we got rid of that. PHP was one of the first web languages that actually helped make dynamic content that didn't look like it was a bunch of blocks. It allowed us to add things like clickable buttons with animations, like scrolling content, things like that. But PHP is a bit of an older language, and although it is still used today, it's not as new and it doesn't support as many language features as modern languages like JavaScript and Python. And finally, we have JavaScript, the ubiquitous JavaScript. With JavaScript, we can basically do anything that we want directly in the browser. We can program games with JavaScript. We can add dynamic content with JavaScript. We can create something called Discord in JavaScript. Who here uses Discord? Yeah, you guys are using JavaScript. Anybody who is downloading actually the Discord client is actually downloading a special JavaScript engine that runs the same web code just directly in a dedicated application. So you remove the overhead of all of the other web stuff. Now, what comes with being able to do a bunch of stuff is having to program a bunch of stuff. So if you write something in JavaScript, it means that you have to program all of that functionality in. And for anybody who has seen the black hole that is Node.js, well, there's a whole bunch of stuff that you really have to deal with. Managing web servers. We do like Apache and Nginx over something like Microsoft's IIS implementation because IIS is kind of slow, kind of old, doesn't look great. Easy to use though. Just like before, we use apt install, Nginx or Apache 2, and then MySQL Server or MariaDB Server. One important thing to note is that MySQL Server is technically not an open source project. It is a semi-open source project. So some of the code is contributable, it is available, but at the end of the day, the decisions are made by its parent company. MariaDB was forked directly from MySQL a while ago, and it basically maintains a lot of the same functionality, except in a completely open source format. So if you want something open source, you can go with MariaDB. If you don't care, you just want the common thing that everybody uses, you can go ahead and use MySQL Server. The same thing as before, systemctl, enable, disable, start, stop, restart, one of the things above to manage your services. Now, you could go through and you could set up the MySQL Server all the way from scratch, which means you have to go in, you have to configure a whole bunch of things, you have to make sure to add a root user, you'd have to make sure that people... What we're going to do instead is we're going to run a command called sudo mysql secure installation. This is a bash script that comes with MySQL installations and also my MariaDB installations. And it basically helps you go through the process of setting up your first database and the first couple of users and a couple of security settings in there. It's a really, really easy way of setting things up. Modules. As I said before, Apache 2 and Nginx are extensible. This means that you can add additional functionality using modules. Apache 2 does tend to have a little bit more like module, it does tend to have more modules available for it than Nginx, which is one reason why people still use Apache these days. But both of them are still extensible. And PHP also has a whole bunch of extra modules to help extend program functionality. If anybody here is familiar with Python, then you know that you can basically import whatever code you want, and you can add whatever functionality you want with Python. In a similar way, if you install certain packages to your PHP, then you can add a bunch of extra functionality. So a couple of important modules here. For Apache 2, we have something called mod security. As you might imagine by the name mod security, it adds a whole bunch of security features to Apache 2 to help it at least weed out bad connections a little bit better. Mod proxy allows you to set up proxies. Mod SSL allows you to set up SSL connections for HTTPS. And mod deflate does something with files. I forgot exactly what. For Nginx, it's a little bit harder to find these files, and sometimes you will have to build it with source, which is a little bit annoying if you've built a program from source. But we have Nginx RTMP, which is useful for some WebRTC and WebSocket stuff, and Lua SSL Nginx module, which helps you use Lua with SSL with Nginx. And in PHP, we have a whole bunch of them. In fact, I think I remember seeing one time on a computer 50 PHP modules installed at the same time. You probably don't need all 50 of those. But some of the more important ones that you'll find are PHP FPM, PHP XML, which adds XML support, PHP curl, which adds curl support, and PHP MySQL, which adds support for MySQL. WordPress. Who here has heard about WordPress? That is a lot less people than I thought. Okay, WordPress is a content management system. What this means is it's a fully built-in website that basically is completely bare bones. It has no content. It just has like the interface, it has styles, everything built in. So all you need to do is add your content. WordPress got famous back in the day for allowing people to create their own blogs. So in fact, you can still go to wordpress.com today, and you can still go in and you can still set up your own blog using WordPress. And one of the great things about WordPress is that it was specifically designed for a LAMP stack. So if you if you have a Linux server and you're told to install a LAMP stack, you're told to install WordPress, all you have to do is install a LAMP stack. And from there, you can just go ahead and download the WordPress stuff, configure a couple of things, and bam, you have a full functioning website. It's great. And WordPress is also highly extensible. So there are thousands upon thousands of modules that are written for WordPress that extend its functionality. You can, add things like content generators, static content, loading, just to name two. But just because of that extensibility, well, what if somebody doesn't exactly write the most well-written module? What if, for example, I leave a backdoor in my module? That's not good. So WordPress is also very infamous for allowing many different hacking incidents just because people didn't secure their WordPress installation. WordPress itself is not inherently vulnerable to things, but adding in a whole bunch of plugins using code that might not necessarily be the most safe, that is what opens up holes for people to get in. In fact, one time when I was in 7th grade, no, not 7th grade, 11th grade, I had a WordPress server open, and somebody in my school who was a hacking genius, he basically hacked into my WordPress server within 10 minutes, even though I had taken down the WordPress site 3 days before. He still got in, which is crazy. Oops. All right. Does anybody have any questions about web servers and web content before we continue on? Apparently not. All right. Let's go ahead and cover the last couple of things before we wrap up for the day. We're going to go ahead and cover DNS, SMB, and I'm going to talk about the systemctl command and what it actually does. The first thing is DNS, or domain name service. If anybody has ever used google.com or microsoft.com or my.cpp.edu, those are very easy for easy web addresses for us to read. I mean, who wants to type in 107.134.160? I'm not going to remember all of those. I'm going to remember google.com though. So what domain name service does is it helps you translate cool names into computer names. Pretty simple. Most often, you're going to use one of the publicly available DNS servers. Google has one, Cloudflare has one, all of the individual DNS providers, they have one. But sometimes you want to set up your own DNS servers. So for example, I have, 5 computers, and one is called alpha, then we have beta. I forgot what the third Greek letter is, but okay. And you just give a name to each one. And let's say my domain is entangled.net. Then you can do alpha.entangled.net. And if you have a DNS server, every computer in that network will recognize alpha.entangled.net. Pretty useful if you have multiple VMs or multiple computers within your own home network. What you want to do if you want to set up your own DNS server in Linux is you want to use a software called Bind or Bind9 if you're specifically using a Debian-based distribution. If you're going to use one of those, then you're going to go ahead and use a config file in etc bind called names.conf.options. Any questions about DNS before we move on to SMB? No? Okay. SMB stands for Server Message Block. It is another way to share files. While I would love to joke that this is basically only a Windows file sharing thing, it really isn't, and it actually is incredibly useful. SMB can also be used to share printers, so you can share your printer that is directly connected to one computer, share it to every other computer in your network, and you can even use Samba as a domain controller, which is kind of crazy. I don't recommend it. If anybody wants to set up Samba as a domain controller, I think you win the Medal of the Year award because that's really annoying to do, and it's not exactly the easiest thing. The most popular implementation of SMB is Samba. And if you want to set up a quick and easy file server for your entire house network, Samba is the quickest way to do it. Not the most recommended, but it's quick. Finally, we're going to go ahead and talk about systemctl. Now, I briefly touched on systemctl as a way to start, stop your services, but what does it actually do? In the background, this is the last slide. Okay, in the background, systemctl runs off something called systemd. Systemd is kind of an overarching background service in Linux that basically manages every running process. It replaces the older thing called systemv. So if anybody did sudo service list all or start stop, you don't do that anymore. What you do is systemctl start, stop, enable, disable, restart a process. Now, start and stop are self-explanatory. If you start a process, you have it run. If you stop a process, you kill it. Enable and disable are special words that basically mean you're going to have this server start when the computer starts, or turn off that functionality so that it doesn't start when the computer starts. This is great if you have a dedicated Minecraft server, for example. If I don't want to go in and have to type in, java.jar and so on and so forth to start up the server, I can just write my own service file and then have it enabled upon system startup so that your services start up when your computer starts up. Does anybody have any questions about systemctl? Oh yeah, and systemctl is universal amongst Linux distributions, mostly universal across the popular Linux distributions. If you use any Debian-based or Red Hat-based distributions, it's going to be managed with systemd if you're using a modern version of it and not something from 2014. All right, and with that, we're going to go ahead and wrap up our Introduction to Linux Services meeting. This Friday, we're going to go ahead and do a little bit more of a hands-on introduction to the exact same concepts that I talked about today. Thank you so much for coming, and we hope to see you on Friday.
Also sign in if you haven't. There's the QR code right there.